Okay, if possible, ask others to join. Okay. Uh, Anyway, I will upload this to the LMS. Then you can refer it later. Okay. If someone not possible to join with the lecture, he or she can uh, refer in the LMS. Okay. Okay. So we are going to start the LO2. Okay. So that is the transforming the continuous time into uh, discrete time signal. Okay. Actually, digital system. Here we have to discuss how we convert analog signal into digital signal. Okay. So that is very important part. Okay. Okay. So first thing is, I hope in signal and system, in signal and system, you have learned about some types of signal. Okay. Okay. Signal types gana gata. Okay. Here we classified signals into different groups. Okay. Maybe you can remember. Okay. So based on the time property, time axis. Okay. Based on the time property or time axis, we can group a signal into two categories. Maybe you can remember continuous time and discrete time signal. Okay. And based on the repetitive of the signal, we have classified a signal as a periodic and non-periodic. And based on the amplitude property, we uh, categorize a signal as analog and digital. Okay, I hope you can remember these three types of signals. Okay. Okay, as a recap, I will quickly tell you. Okay. So continuous time signal. Okay. Continuous time signal. Means the time. Okay. So here the name implies the type of the signal. Okay. So if the time is a continuous variable, හරි ඒක කට්ටිය දන්නවා සිග්නල් එකක් කියන්නේ වේරියබල් සාමාන්‍යයෙන් අපි ඉගෙන ගන්න සිග්නල් වල වේරියබල් දෙකක් තියෙනවා. Okay. So we are learning about one dimensional signals. Okay. And there maybe two dimensional. So we are focusing on two dimensional signal. Okay. So there we have two variables. Sorry. අපිට variable දෙකක් තියෙනවා. Okay. So normally we called x variable, independent variable, and another dependent variable. Okay. And if you consider voltage signal, normally we take time as an independent variable. හරි. Independent variable එක විදිහට ගන්න time එක. Then dependent variable is the voltage. Okay. And also this voltage is referred as amplitude also. No? Make up amplitude right? It may be a current, voltage, or anything. Okay. So y-axis also referred as amplitude. Okay. Okay. So the variable we have two variables. Okay. We have two variables. The independent variables, time. Okay. If the time is a continuous variable, we call this continuous time signal. Okay. Continuous time signal. Okay. So what is continuous variable means? Continuous means, okay. So if you have a signal like this, okay, So if you take any 2 points, any time 2 points, any two time points, හරි ඔකට මොකක් හරි time point දෙකක් ගත්තොත් එහෙම within this time interval there are infinite number of all the values are there. Okay, all time values are there. Okay, all time values are there. For example, if this is 1 and if this is 2, let's say that this is 1 second and this is 2 second. Okay, so between 1 second and 2 second, every other points are also there. So you will have some decimal values. Okay, for example, if you take one decimal place, you will have 10 values here. 0, 1.1, 1, 1.1, 1.2, likewise up to 2. Okay, so 10 points, maybe 10 values are there. If you take 2 decimal point, you will have 100 values. If you have 3 decimal point, you will have 1000. Okay, likewise, if you get more decimal value, you will have more number of values. Okay, so here you can't count the values. Okay, මෙතන ඔකටට හරියම count කරන්න බෑ value කීයක් තියෙනවද කියලා. Okay, there can be infinite number of values. Infinite number of values. Infinite number of values. Okay, so these are called continuous time signal. Okay, if the time is a continuous variable. Continuous variable means that, okay, between any 2 points, there are infinite number of values, so uncountable values. Okay, all the values are there. So it is not countable. Okay, the values you can't count, not countable. Okay? You need to keep remember this one. Okay, මේක මතක තියාගන්න ඕන. හරි, signal point දෙකක් අතර ඔය කට්ටියට infinite number, ඒ කියන්නේ count කරන්න බැරි ඔක්කොම number තියෙනවා නම් ඒක ඔය කට්ටියට count කරන්න බෑ. ඒ කියන්නේ එතන infinite number of levels values තියෙනවා. එතකොට ඒ වගේ එකක් තමයි continuous variable එකක් කියලා කියන්නේ. හරි. Discrete time means, discrete time signal means, okay, discrete time means, okay, any 2 points, any time values, any 2 points, okay, you have countable values. Let's say that you will have some values like this. Okay, like this. So you can see it is not continuous. Okay, these values are not continuous. Make එක දිගටම යන්නේ. Continuous means එක දිගට යනවා කියන එක නේ. Continue. The values are not continuing. Okay, so these are not continuous. Okay, so we have one value here, 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 one value here. Okay, so between this one and this one, you will have countable values. 1, 2, 3, 4, maybe. Okay, so 4 values are there. You can count. For finite number of values are there. Okay, එතන තියෙන්නේ count කරන්න පුළුවන් ගානක්. එහෙම නැත්නම් finite values. Okay, so this is called discrete time signal. Okay, so that is continuous time and discrete time. Okay, and I think maybe you can remember the periodic signal and non-periodic signal. Okay, we will talk that one also later. Okay, maybe you can remember. Okay, I think you should have the idea. Okay, we have do some calculation also. No, we have done some calculation also. අපි ගණනුත් හැදුවානේ. Signal එක period එක හෙව්වා. Fundamental period එක හෙව්වා. Signal වල, sine signal වල. හරි. Signal repetitive ද කියලා බැලුවා. Repetitive නම් fundamental signal, fundamental period එක හෙව්වා. ඒ වගේ ගණන් අපි හැදුවා. හරි. Okay. Then can anyone tell me what is analog signal? What is analog signal and what is a digital signal? Can anyone tell? What is analog signal and what is a digital signal? කාට හරි කියන්න පුළුවන්ද මොකක්ද analog signal එකක් කියන්නේ මොකක්ද digital signal එකක් කියන්නේ කියලා? ඔකට බය නැතුව කතා කරන්න. You can talk with me, okay? If the answers are wrong, that is okay. Don't worry about that, okay? You can talk with me. What is the analog signal and what is a digital signal? Okay, I will tell. I think you know this, okay? You know this also. If I draw it, you can maybe you can check, okay? So if I draw a signal like this, okay, and signal like this, you know what is analog signal and what is the digital signal, okay? Okay. If this is a signal one and if this is a signal two, what is the analog signal and what is the digital signal? Tell me what is the analog signal? One or two? What is the analog signal and what is the digital signal? Focus the analog signal like focus the digital signal like. Which one is the analog signal and which one is the digital signal? Okay, I will tell that. Okay. Uh, but yeah. Okay. This one is the analog signal and this one is the digital signal. Okay. Thanks for the answer. Okay. Okay, I will explain what is analog signal and what is a digital signal. Okay. So continuous time and discrete time, you decide it based on the time value or x-axis value. X-axis value. Okay. Independent variable. Okay. If the independent variable is continuous, have all the values, it is called continuous time. If the x-axis value has discrete value, okay, it is called a discrete time signal, okay. Now, analog signal and digital signals are categorized based on the amplitude property, okay, amplitude property, okay. So, for example, let's take this kind of signal. We will take this kind of signal, okay. So, if I take any two values, okay, let's say that I will take this value, okay, and this value. This is the amplitude axis. Sorry, make it amplitude axis. Okay, amplitude axis. Okay, let's say that this is a voltage signal. Okay, let's say that this is 2 volt and this is 3.5 volt. Okay, tell me how many voltage levels are there? How many voltage levels are there between 2 volt and 3.5 volt? Tell me. Please tell me. හරි මට කියන්න දැන් 2 volt 3.5 volt අතර කොච්චර voltage values තියෙනවද? දැන් මේවා voltage values. හරි. එහෙම නැත්නම් අපිට කියන්න පුළුවන් ඒවා voltage levels කියලා. Okay. So tell me between 2 volt and 3.5 volt according to the signal, how many voltage values are there? How many are there? 10, 100, 1000 or infinite number? Please answer. ඒ දෙක අතර කීයක් points තියෙනවද? How many values are there between this 2 volt and 3.5 volt? How many voltage levels? Okay, it is same as like this, no? Okay, it is same as like this. Okay. So you can see that all the values are there. All the values are there. The amplitude is continuous value. It is a continuous value. Okay. From 2 volt to 3.5, all the values are there. From 2 volt to 3.5, all the values are there. All the values are there. Okay. So there are infinite number of amplitude levels. Infinite number of amplitude level. Amplitude level. Okay. For an analog signal, there are infinite number of amplitudes level between any two amplitudes. Okay. Okay. There are infinite number of amplitude levels. Okay. You can't count the amplitude levels. Okay. But for a digital signal, if you get a digital signal, you have finite number of amplitudes level. Maybe like this. Okay. If you have a signal like this, okay. So you can see that this is one amplitude level, this is another level, this is another, okay. And this is another amplitude, this is another, like this. Okay. So there are countable amplitudes, maybe 1, 2, 3, 4, 5, 6, 7, 8. Okay. 8 amplitude levels. You can count the amplitude level. Okay. You can count the amplitude level. Amplitude level count කරන්න පුළුවන්. හරි. එහෙනම්. Okay. So this is digital signal. This is a digital signal. And this is an analog signal. Okay. This is a digital signal and this is an analog signal. Okay. So if you consider digital signal, again tell me how many amplitudes are there. If you get the digital signal, how many amplitudes are there? There are finite number of amplitudes. Finite number of amplitudes. Okay. You can count. Okay. You can count the number of amplitudes level. Okay. Number of amplitudes level. You can count. Okay. That is a digital signal. Okay. So you have analog signal and you have a digital signal. So you know now you know about digital signal and you know about analog signal. Okay. 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 Now tell me. Okay. So you know that. So we have learned that for a digital signal, there are finite number of amplitude levels. Okay, I think it is clear. Okay, finite number of amplitude levels. It can be 2, it can be 3, it can be 4, it can be 5, 8, 100 or something, but countable. It should be countable. Okay, okay, tell me, um, most probably for a digital signals, we are using for circuits. How many number of amplitude levels we are using? Tell me. I think you know this answer. Okay? How many amplitudes are being used? Okay? Are being used for normal digital signal, normal digital system or signal. How many amplitudes levels are being used for normal available? So you have learned, you have used some digital signals, digital systems, and you also know about some digital signals, no? Okay. So normally how many amplitudes level we are using for current systems? For current digital system, how many amplitudes normally? Most probably we are using how many amplitudes? සාමාන්‍යයෙන් අපි amplitudes level කීයක්ද පාවිච්චි කරන්නේ? How many amplitudes level we are using? Please give me answer. We are normally using 2 amplitudes level, no? We are normally using 2 amplitudes level. Okay. One amplitude level you normally referred as 1, and another amplitude you normally referred as 0. Okay. So yeah, you are using 2 amplitude levels. Okay. One level you are using as you are referring as 1, and another level you are referring as 0. Okay. It may be 5 volt or 0 volt. It may be 5 volt or minus 5 volt. Okay. It is depend on the several system. It is depend on the design of the system. Right? Okay, you can choose any value. Okay. So normally you are using 1 volt and 0 volt. Sorry, 1 and 0, 2 amplitudes level. Uh, one amplitude level is shown using 1 and another is from 0. Okay. So 2 amplitudes levels we are using for most current systems. Okay. Current digital systems. Okay. Okay. Now tell me. Okay, I think we have discussed this in our later class also, previous class also. Okay. I told you that real world is analog. Real world is analog. Real world is normally analog. Okay. For example, if you get a temperature changing with respect to time, okay. So temperature is not changing at once from one level to another level. Okay. It is continuously varying like this. Okay. Um, if you consider a growth of a tree, Okay, the tree is continuously growing. Okay, it is not growing level to level. Okay, if a plant is 1 centimeter, after 2 days, it will not become 2 centimeter at once. Okay, gradually it is growing. Okay, so between this 1 and 2, all the values it takes. Okay, okay. So you should understand that real world is analog. Okay, that is very important. Real world is analog. But we develop digital signal. Why we develop digital systems? If the real world is analog, okay, why we are using digital systems? Okay, in real worlds there are many levels. Okay, but when we are processing, we are always concerning about 2 levels. Okay, why? Okay, so I think I will tell you why. Okay, I will tell you why, and also you should try to understand. Okay, so there are many reasons why we like digital system. Okay, why digital systems are more preferred. Okay, so there are many reasons. Okay, the first one is, so you know that for digital signal you have finite number of levels, finite number of levels. In analog signal there are infinite number of levels. Okay, so first thing is it is easy to deal with. Okay, it is easy to deal with finite number of levels rather than infinite number of levels. No? Okay, okay. So the processing will be easy because there are only 2 levels. Okay, in digital signal there are only 2 countable levels. Okay, most probably there are 2 levels. Okay, so the first thing is processing will be easy. Processing will be easy. Okay, for example, if you send, let's say that you are talking to a microphone. Let's say that you are talking to a microphone. Okay, let's say that someone is talking to a microphone. Okay, okay. What is this microphone is doing? It convert your sound signal into electrical signal, voltage signal. Okay, and your sound will be like this. Okay, this kind of sound you will have. Okay, time, voltage. Okay, so you know that the sound is a real world parameter. So it is analog. Okay, so your sound is analog. Okay, but if you want to transmit this sound, now you are in previous we are using analog transmission. Okay, but now we like to transmit this as a digital, as it is as digitally. Okay, rather than transmitting analog signal, we like to convert it to a digital signal and send it. Okay, uh, because the processing is easy. Okay, so you know that when we are transmitting the signal, sometime noise can be added. Okay, so there are infinite number of levels. So noise filtering is maybe hard. Okay, but if you are converting this signal into 2 levels, okay, maybe you can easily remove the noise from it. Okay, so that is why I tell that processing is easy. Okay, processing will be easy. Maybe noise filtering, amplification, all all things will be easy. Okay, so that is the processing. Okay, and the second one is design is easy. Design is easy. Okay, so you know that maybe you have learned digital electronics. Okay, you have learned digital electronics. Have you learned digital electronics? ඔකට digital electronics ඉගෙනගෙන තියෙනවා. Please tell me. Have you learned digital electronics? Maybe the gates or gate XOR, not gate, and gate. Okay, I think you have learned the subject. Okay, there you have to learn that kind of electronics components. Okay, and using truth table, maybe you have designed some electronic circuits also using those gate. Okay, okay. I think you have developed uh, adder circuits. Okay, multiplex circuits. Okay, maybe still not. Okay, I think you know about the digital component. Okay, XOR or not, and those gates. Okay, and using the truth table. If you are given the truth table, based on the truth table, you can easily design the circuit using that component. Okay, okay. But I think you already learned about the transistor. Okay, you have already learned about the transistors also. Okay, so if I ask you to make a on-off circuit, LED on-off circuit using a transistor, can you do that? Using a transistor and maybe a capacitor, can you uh, design a circuit to blink a LED? Transistor එකකුයි capacitor එකකුයි දුන්නොත් එහෙම ඔකටට හදන්න පුළුවන්. මොකක් හරි බැටරියක් දුන්නොත් එහෙම LED එක on off වෙන signal circuit එකක්. Okay. Maybe you can't design it. Okay. Maybe you can refer the internet and you can do that one. Okay, but that is not design. Okay. Okay. That is just a rebuild of a circuit. Okay. So if I ask you to design it, okay, you can't design. Okay, it is hard actually. It is not easy. Okay, because you need to know the mechanism of a transistor and the mechanism of a capacitor very well. Then you need to use that property and characteristic to design your circuit. Okay, so it will be very hard. Okay, so this analog design using transistor, resistor, capacitor. Okay, okay. If we are using that kind of component, if we are going to make analog circuit, it will be very hard. Okay, it is not easy. But if you are using, if you have only two levels, and if you can construct the truth table somehow, then your design will be easy. Okay, so the second reason is the design is easy. Okay, the third reason is analysis also is easy. Okay, and there are other reasons also. Okay, and also digital signal use low power, but analog system use high power. Okay, so we have a problem with the power now. Okay, we need to save the power. Okay? So digital systems will use low power rather than analog signal. Okay, so there are many advantages like this. Okay, so maybe you can try to explore what are the other things, what are the advantage of analog system over digital systems. Okay, so that is in your learning outcomes. Okay, okay, that is in your learning outcomes. Okay, so try to try to collect some information. Okay. Okay. What are the advantages of digital system? Digital system or digital signal processing over analog system. Analog system or analog signal processing. Okay. So you can explore more. Okay. Okay. So anyway, these are the basic fundamental reason that we like to use digital system rather than analog systems. Okay. Okay. Now I told you that real world is analog. Real world is analog. Okay. But now we have digital system. Now you have digital system. Digital system will use two levels, two amplitude levels. Okay. Analog system have infinite number of amplitudes level. Infinite number of amplitudes level. Okay. Amplitude levels. Okay. So if you want to digitally process a signal, okay, if you want to digitally process a signal processing means actually basically we have uh, several processing techniques. Okay, one is storing a signal, okay, filtering a signal, amplifying a signal, okay, and converting a signal. Okay, so these are the basic signal processing things we are using: storing, filtering, amplifying, and converting. Okay. So if you want to, let's say that you want to store analog signal, okay, you have analog signal like this, okay, analog signal, okay. Now you want to store this signal in a RAM, okay, in a RAM. Okay, now you want to store this signal in a RAM. The RAM is a digital system, okay. So it has only two levels, 1 and 0, okay, 1 and 0. So if you consider RAM, there are many memory location, okay, and this is one memory location, this is another, like this, okay, and this memory location can will have several, we called it bits, no, bits. Bit means these levels, okay, voltage levels, okay. So you can store here 1 0 1 0 like this, okay, like this, okay. So if you want to store the signal, this kind of RAM, can you directly do it? ඔකටට මේ වගේ සිග්නල් එකක් දීලා ඩිජිටල් RAM එක ඕක ස්ටෝර් කරන්න කිව්වොත් එහෙම කෙලින්ම ওই සිග්නල් එක RAM එකේ ස්ටෝර් කරන්න පුළුවන්. You can't do this because this has infinite number of amplitudes level, but here you have only two number of amplitudes levels. Okay. Normally we use 0 and 1. Okay. Also referred as bit. Okay. So somehow you have to convert this infinite number of levels into two levels. Okay, you have to convert it, then you can store it. Okay, this conversion we call analog to digital conversion. Okay, normally we refer it as ADC, analog to digital conversion. Okay, analog to digital converter. We have this is an electronic device. Okay, we have analog to digital converters. Okay, you can find in the internet. Okay, using op amps, we can easily design analog digital converters. Okay, we can very easily design analog digital converter using op amps. Okay, maybe for your digital electronics subject, you will learn this. Okay, how to design analog to digital converter using op amps. Okay, so what is the basic function of the ADC, analog to digital converter? What is the basic function? It convert analog signal into digital signal. It convert analog signal into digital signal. That is the analog to digital conversion. Okay, converting analog signal into a digital signal. Okay. Okay, so this is analog to digital conversion is very important because you know that real world is analog, but we like digital system. We use digital systems. Okay, so we have to use the analog to digital converter to convert it. Okay, for example, again I will come to that example. Okay, let's say that some person is okay talking to a microphone. Okay, so it generate an analog signal like this. Okay, sound signal like this. Okay, this kind of signal it generate. Okay, now if you want to digitally process this, okay, first you have to convert this signal into a digital signal. Okay, so you have to use the analog to digital converter. Then you will have a digital signal which you have only two levels like this. Okay, you will have this kind of two levels. Okay, then you can process it. You can do anything. Okay, you can amplify it, you can filter it. Okay, you can send it. Okay, anything. You can store it, anything. You are doing the processing. Okay, now again you need to hear the voice. Okay, after processing you need to hear the voice. Okay, now you will have digital signal. Now this processing is also digital. Okay, so output also will be a digital signal. Okay, but if you want to convert this into sound, okay, maybe using a microphone, sorry, using a speaker. This is a microphone, okay, and this is speaker. Using the speaker, okay, so you know that sound is analog. Okay, so we have to feed an analog signal to a speaker, otherwise the speaker will not create the sound. If you send this signal to this one, okay, so it may be only give the beep sound. Okay, it will not give a voice. Okay, so what you have to do is, again you have to convert this analog signal into digital. Okay, sorry, digital signal into analog. Okay, so that is we call digital to analog conversion. Okay, digital to analog conversion. Digital to analog conversion. Okay, digital to analog conversion, and we call this equipment or this component as DAC, digital to analog converter. Okay, so once you give your digital signal into a digital to analog converter, you will have an analog signal. Then you can feed that analog signal into the speaker. Then you can hear the voice again. Okay, so for any digital system you should have these 3 steps. Okay. For any digital system, you should have these 3 steps. Okay. Analog to digital conversion, then the processing after digital to analog conversion. Okay. So this is very important. For every digital system you are using this you have to go through these 3 processes. Analog to digital conversion, processing we don't know any processing, and then digital to analog conversion. Okay, so I told you that analog to digital converter can be easily designed using op amps, and also you need some resistors. That's enough. Okay, you can design the analog to digital converter using op amp and resistor, and digital to analog converter only by resistor. You can use only resistor. Using a resistor ladder, you can easily convert digital signal into an analog signal. Okay, so we are not going to design a circuit here. Okay, we are not going to design a circuit here. Okay, the circuit design is in digital electronic subject. Okay, in that module you will learn those design. Okay, analog to digital conversion and digital to analog converter. Okay, but the design is very easy. Okay, and anyone can do the design. Okay, now we are mainly focusing on these 2 conversion. Okay, analog to digital conversion and digital to analog conversion. Okay, so first we will see analog to digital conversion. Okay, first we will see analog to digital conversion. Okay, actually for analog digital conversion there are 3 steps. Okay, in analog to digital conversion there are 3 steps. Okay, you should know these 3 steps. These are very important. Okay, sampling, other step we called as quantizing, and other step we called as encoding. Okay, sampling, quantizing, and encoding. Okay, so these are the 3 steps, 3 basic fundamental steps that we convert analog signal. We are giving analog signal and we can get output digital signal. We will have the output as a digital signal. Okay, we will have digital signal as output. Okay, so these 3 processes are there: sampling, quantizing, and encoding. Okay, so first we have to focus in on sampling. Okay, first we have to focus in on sampling. Actually, most of the weightage will be on sampling. Okay, so we are learning LO2 now. We are learning LO2, learning outcome 2. I already told you. Okay, so the first step of analog to digital conversion is sampling. Okay, we are going to focus in this sampling very much. Okay, so you should be thorough with the sampling. Okay, you will have some final question. You will have maybe 1 full question for your end semester exams from this sampling section. Okay, so sampling is very important. You should understand this thoroughly. Okay. Okay, so we will see the basic things about the sampling. Okay. Okay. Now again, I will come to continuous time signal. Continuous time signal. Okay. So continuous time signal. Okay. So you know the continuous time signal. What is a continuous time signal? So there are infinite number of time values. Okay. So that is the continuous time signal. Okay. So if you have a continuous time signal, that signal will be like this. This is a continuous time signal. Okay. This is a continuous time signal. Okay. And as well as this is an analog signal. This is an analog signal. Okay. This is a continuous time, and also you can see that there are infinite number of amplitude level. So this is analog signal. Okay. And also continuous time signal. Okay. And uh, before convert this signal to a digital signal, first we have to convert this signal into a discrete time signal. Okay. Okay. That is the first step of the ADC. Okay. Analog to digital conversion first step is converting a continuous time signal into digital time signal. Okay. So you know that real world is analog as well as it is continuous time. Okay. Real world is analog as well as continuous time. Okay. Okay. So continuous time signal. Okay. Or this analog signal. Okay. Don't don't misunderstand. Okay. Continuous time analog means there are two types of signal. Okay. Okay. Continuous time and analog signal means two type of signals. Okay. Uh, okay. For example, no, I'm not. We will see them later. Okay. Uh, uh, so, uh, and you can say that all analog signals are continuous time also. Okay. All analog signals are continuous time. Okay. But all continuous time signals are not analog. Okay. I will explain it later. Okay. But all analog signals are continuous. Okay. So now we are going to convert analog signal into digital. Okay. So that signal will be definitely a continuous time signal. Okay. Before converting it to a digital signal, first you have to convert it to a discrete time signal. Okay, that is very important. Okay. So discrete time signal. Okay. So you have to convert this to a discrete time signal. Okay, it may be like this. Okay, this kind of signal. Okay. Maybe this kind of signal you should have. Okay. Actually, uh, actually here you have only the voltage values like this. Okay, voltage values like this. Okay, and there are corresponding time values. Okay, like this. Okay. So you have to convert this continuous time signal into this kind of discrete time signal. Okay. Actually, this process we call as sampling. This process is called as sampling. Okay. So what is sampling? What is sampling? Can anyone tell me what is sampling? I have told you. මොකද්ද sampling කියන්නේ? What is sampling? Now I told you what is sampling. Sampling is nothing but converting, okay, converting continuous time signal into discrete time signal. Discrete time signal. Okay. So that is sampling. Okay. Actually, in DSP, in digital signal processing, I think you can remember that in signal and system, we are mainly focusing on continuous time signal. Okay, we are mainly focusing on continuous time signal. Okay, we analyze the continuous time signal using Fourier analysis. Okay, using Fourier series and Fourier transform. Okay, in signal and system. Okay, you have already familiar with this. Okay, but in DSP, digital signal processing, we are mainly focusing on discrete time signal. Discrete time signal. Okay, so we have to analyze the discrete time signal using Fourier transform and Fourier series. Okay, so maybe it is in LO3, okay, learning outcome 3. After this, we can go for the analysis of the signal, okay. What I want to tell you is that in DSP, we are mainly focusing on discrete time signal, okay. So that is the first step, okay. Con Converting the continuous time into discrete time signal is a first step of a DSP, of the DSP module, okay. Okay, so so you have to learn. So I think your first assignment also will be based on the sampling. Okay, so you have to learn this sampling very well. Okay. Uh, okay. Um, okay. Uh, I will ask you. Okay, I will tell you. I will tell you like this. Okay. Let's say that you have a signal generator. Okay, you have a signal generator. I think you know signal generator, no? You know signal generator. You have used it, okay? You have used the signal generator, no? Okay. So let's say that you generate the sinusoidal signal. Okay, you generate a sinusoidal signal. Okay. So let's say that you are generating a sinusoidal signal sine 5 1. This is, let's say that 5. Okay. So this is your sinusoidal signal. Okay. This is your sinusoidal signal. Okay. First, tell me this is a continuous time or discrete time. Tell me this is continuous time or discrete time. This sampling is very important. Okay. Tell me this is continuous time or discrete time. So signal generator will give you a continuous time signal. Okay. So I told you that you are going to generate the signal using the signal generator. Okay. The signal generators are in your lab. Okay. So you are going to generate this signal. Okay. So definitely this is a continuous time signal. Okay. So can you draw this signal? Can anyone tell what is the frequency of this signal? What is the frequency of this signal? In signal and system, you have learned about 5 basic signal. 5 basic signal. Okay. Continuous time signal. Okay. Continuous time signal. 5 basic continuous time signal. One is unit impulse signal. Other is unit step signal. Complex exponential signal. Complex signal. Complex exponential signal. and sinusoidal signal. You have learned these 5 basic signals. These are called basic signals, okay? These are called basic signals. Why these are called basic signals? I think we have discussed these things, okay? Because you can, using this signal, you can construct other signal also. Other arbitrary signal, any arbitrary signal can be decomposed into these basic signals, okay? These are somewhat like building blocks of the signals. මේ නිකන් building blocks වගේ, ගඩොල් වගේ. හරි? අනිත් ඕනම සිග්නල් එකක් අපිට මේ සිග්නල් වලින් හදලා පෙන්වන්න පුළුවන්. හරි? Mathematically. Right? So that is why these are called basic signals, okay? And this is mathematical signal. This is completely mathematical. This is not a practical signal. Okay, this delta T is not a practical signal. Okay. And this is somewhat practical, but not total. Okay. And this is not a practical signal also. This is also a very mathematical signal. There are no signal called complex signals, okay? But this is a practical signal. Practically, we can generate this signal, okay? We can practically generate this signal. Actually, signal generator, you can generate this cosine signal, okay? Now tell me, what is the frequency of this signal? Can anyone tell me what is the frequency of this signal? Okay, so this is the basic this is the basic format of the signal, sinusoidal signal, cos 2 5 f naught t plus 5. Okay, this is the normally the mathematical representation of a sinusoidal signal. This cos also can be sine. Okay, this is cos or sine. Okay, both are same. Both are sinusoidal signal. Not both are same. Okay. Only a phase, there is a difference between the phase shift, okay? But basically both are sinusoidal signals, okay? Okay, and tell me what is this parameter and what is this parameter and what is this parameter. This is very important, okay? You have to very much thorough with this, okay? මේක හරියට බැයි නම් ඔය කට්ටියට මේ ෆයිනල් එක්සෑම් එකේ එක ගානක්ම බැරි වෙනවා හරි හරි ඒකින්ද මේක හොඳට දැනගෙන ඉන්නවා right මේක තමයි සිග්නල් එක mathematical representation එක sinusoidal signal එක හරි මට කියන්න මේක මොකද්ද මේ පැරාමීටර් එක මොකද්ද මේ පැරාමීටර් එක මොකද්ද what is a what is f what is phi what is a what is f and what is phi tell me what is a I need the answer okay what is a What is it? Actually, I want to do some online session before the physical interaction, okay? Because in physical interaction, um, we are just doing some activity, okay? We will do some activity, okay? But all the lectures we will do as online, okay? Then you can refer it later, okay? But in physical interaction session, we are only doing activity, okay? Activities, okay? So I like to do one or two online session before physical session actually, because then we can do activity very well, okay? I think you can do the activity by yourself without my help, okay? Okay, tell me what is this A, what is this F, and what is this 5, okay? Please tell me. Can anyone answer? Are you there? කාට හරි කියන්න පුළුවන් මොකද්ද A කියන්නේ මොකද්ද F මොකද්ද 5 කියලා. අපි මේවා ගැන කතා කරලා තියෙනවා. Please tell me. Okay, I will tell you. This is amplitude. This is the frequency. And this is phase shift. This is phase shift. Okay. Amplitude, frequency, phase shift. Okay. Okay. This is amplitude, this is frequency, and this is phase shift. Okay. So these are the three main parameters of sinusoidal signal. Okay. These are the three main parameters of a sinusoidal signal. Actually, for sampling, we are using sinusoidal signal only. Okay, we are considering sinusoidal signal. Okay, so you have to consider some sinusoidal signal and you have to convert it to a discrete time signal. Okay, so you have to thorough with these properties very well. Okay, otherwise you couldn't answer the exam question. Okay, so this A is amplitude and this is F and this is the phase shift. Okay. A is amplitude, F is the frequency, and 5 phase shift. Okay. So, uh, so maybe you can remember that. Okay. This 25F, 25F also referred as omega. Okay. This 25F, this is also referred as omega. And this omega is called angular frequency. Angular frequency. Okay. Or actually, this is angular velocity, okay, but normally referred as angular frequency. We normally measured it radian per second, okay, and this F measured in hertz, okay. This is omega, and this is F, okay, and also yes, and also omega is equal to 2.5 divided by T naught. T naught is the fundamental period. This is the fundamental period. Fundamental period. Okay. So you should know this, you should remember this three parameters, this relationship. 25F is equal to omega is equal to 2.5 divided by T naught. T naught is the fundamental period measured in second. This 2.5 is measured in radians. Okay. So this omega will be radian per second. This F will be hertz. Okay. Hertz or 1 over S. Like this. Okay. So also you should know this relation. Okay. Now tell me what is, if you consider this signal, okay. So this is a sinusoidal signal. I told you that this can be cos or sine, okay. So definitely this is a sinusoidal signal, and this will be the amplitude. 5 is the amplitude, okay. And this is 2.5, and this 1 is the frequency. This is the frequency, okay. And here the 5 is not there, it is 0, okay. So there is no phase shift, okay. And the 5 is 0. The phase shift is 0. Okay. So I ask you the question, what is the frequency of this signal? That is 1. Okay. That is 1 hertz. That is the frequency of the signal. Okay. So what is frequency means? Frequency means number of cycle per second. Number of cycle per second. Okay. So that is the frequency. Okay. That is the frequency. Number of cycle per second. Okay. Okay. So this is 1 hertz. So how many cycle per second? If this is 1 hertz, how many cycle per second? Frequency means number of cycle per second, no? Frequency F is number of cycle per 1 second. Okay. So this is 1 hertz means for 1 second, 1 cycle. Okay. So for 1 second, 1 cycle. Okay. So if you want to find the time for 1 circle, okay, time for 1 circle, that will be 1 over S. Okay. So this is the 1 circle time. Okay. So F is 1. So 1 is divided by 1. So you will have 1 second. Okay. So for this signal, 1 circle will be 1 second. Okay. So this is a circle. This is 1 circle. Okay. So it will be 1 second. Okay. So this point will be 1 second. And this will be half of a circle. That will be 0.5. Okay. And this is quarter of a circle. That will be 2.5. And this will be 3/4 of a circle. So that will be 0.75 second. Okay. And the amplitude is 5 means the maximum value. Okay. So this one and this one. So this will be 5 volt and this will be -5. Okay. This is how we can draw a signal. Okay. So very easily you can draw. you should be able to draw signal. So that is very important. Okay. So that is very important. Okay. So I will give you 5 signals. Okay. You need to draw these signals. Okay. Before come to the next session, you need to draw this. Okay. Okay. So let's say that the first signal xt is equal to 5 cos 251t. Okay. Let's say that another signal xt. Let's say that this is x1, this is x2 is 20 sine 2500t. X3t is 5 volt sine 305t. Okay. X40 is equal to 2 sine I will also give you a time phase shift here also. Radians we are using. Okay. And this is 305 by. So these are 5 signals. Okay. So you have 5 signals. Okay. And try to draw this signal by your hand. Okay. Draw this signal by your hand. Okay. By your hand. Okay. Don't use MATLAB or something. Okay. Don't use MATLAB or something. Try to draw this with your hand. Okay. Using a paper and pen and a paper. Okay. So try to draw this. Okay. So once you come to the next lecture, you can bring this 5 signal. Okay. Draw them and bring them. Okay. Then we will learn how to sample them. Okay. Before sampling, okay, definitely you should be able to draw a signal. Okay. If you can draw this signal, you can get 10 points. Definitely you will get 10 points for your final exam. Okay. So it is very important. Try to draw this signal. Okay. So these are continuous time signal. Okay. These are continuous time signal. So try to draw these signals. So there are 1, 2, 3, 4 signals. Try to draw these 4 signals. Okay. So try to do this one when you come to the next session. Okay. Okay. We will stop here. Actually, we have talked about the advantage over digital systems. Okay, you should know these things. Okay, advantage of digital systems over analog system. Okay, and the 3 processes that should be in a digital system: analog digital converter, signal processing unit, and a digital to analog converter. Okay, so these processes are very important. Okay, and the analog digital conversion, that is converting analog signal into digital signal. We have 3 steps: sampling, quantizing, encoding. Okay, and we are going to talk about sampling. Sampling means converting a continuous time into a digital time signal. Okay, so those things we have discussed, but to continue, first you should be able to draw continuous time sinusoidal signal. Okay, because we are going to sample continuous time sinusoidal signal. Okay, so first you should be able to draw them. Okay, so please try to draw them as a homework. Okay, and bring it. Okay. Okay, please bring this. Okay. Okay, so we will stop here. Do you have any problem? ඔකට මහා ප්‍රශ්න තියෙනවද කතා කරන්න?